limit. I'm going to be lazy. That means determine the limit of all of these. Okay? Okay. The limit as x, it's a u, but I don't want to use a u. X approaches 1, have x to the 4 minus 1 over x cubed plus 5x squared plus 6x. Numero 2. Should have been ABC. That's the problem. So this first one, what I've always told you to do is plug the 1 in right away and see if you get a 0. Do you? And on the bottom. Is there a problem then? Do you get a 0 on the top? Do you get a 0 on the top? Yeah, so we still do have to if it's in one or the other. Sometimes though you plug it in, it's like 7 over 4. Call it a day. Move on to the other thing. So always check first if you get zeros anywhere. So this is the difference of squares. We get x squared minus 1, x squared plus 1. And then this can factor to x plus 1, x minus 1. And then addition of squares just stays. You can't do anything to that. So we're going to get an equal sign. Make sure you put an equal sign, because this limit equals, right? Equal signs are important. So on the top, I'm going to get x plus 1, x minus 1, x squared plus 1. The bottom, I can take an x out. Remember when you suck, it's often a GCF. So we get x squared plus 5x plus 6, which what multiplies to give me 6 and adds to give me 5, x plus 2, x plus 3. Do we find any fixes here? Is anything working? The way that this is, can anything cancel? No. If this had been a minus 6, sorry, then you could have positive 6 and minus 1, then it would go, right? You could have minus 6. The reason why I gave you this one is because sometimes algebraically doesn't always work, right? And what did I tell you have to do if you can't do it algebraically? What's another method? You can go to your tables. You can see what it's approaching on the left, what it's approaching on the right by decimals, right? Get closer and closer from the left. Get closer and closer from the right and see what decimal it approaches, correct? So I gave you this one specifically because not always does algebra work. It's beautiful when it does. When it doesn't, which sometimes it doesn't on the AP tests, you have to approach from the left and approach from the right. Now, if you're allowed your calculator, this is what you can do. So everyone, go and put this into the main screen, actually, into your y equals. So if you're allowed your calculator, what you're going to have to do because the decimals get taken in and figure that out, it's awful. Type that into your y equals. If you have the alpha y equals the enter button, you're going to use that. If you don't, you have the whole top in brackets divided by the whole bottom in brackets, right? Numerator brackets divided by denominators. And you're putting it in your y equals. Okay, then we want to find what the y could be if I got closer, correct? So we're going to go second trace value always, and we know our x's. On the left of 1, what could I put in? What's close to 1 but doesn't touch 1? What x value? Pardon? 0. Gives me nothing. What's closer? 0.9. It gives me negative 0.3337852, right? Okay? And let's go closer. Second trace value. Closer than 0.9 would be like 0.999. Oh, it's 0.0003334. Okay? What if I want even closer? Second trace value, 0.9999959. That's even closer, right? I'm just getting it like 0.503333. So from the left, what am I approaching? 0, right? So on the left of this, of that, it's approaching 0. Now, if this is a written response on the actual test, on my test or on the AP test, you have to show plugging in 0.9, 0.99, and 0.999999 and show what the actual values are. You could list them in scientific notation like negative 3.33 times 10 to the negative 6. That's totally fine. But you have to actually show your work. You just can't say just 0 and show nothing, right? If it's a written response. Now we're going to approach from the right. What's close to 1 from the right? 1.1 is close, right? So we try that. Second trace value, 1.1. Okay, it's 0.0333195. Okay, what else is closer to 1? How could I get closer, a closer value than 1.1? Yeah, 1.001. Second trace value, 1.001. So when you're on the left, you do 0.99999s, right? When you're on the right, you do 0.0001s. So now it's the scientific notation of 3.33 times 10 to the negative 4. So what are we approaching on this side? 0. And you could show it in a t-table. So therefore, the limit, oh, I can just do it up here. Therefore, this equals 0, right? From the left or right, the first thing, yeah.
What's wrong with having a 0 on the top? Like
The 0 on the top wouldn't have been as big of a deal. The problem is if you have 0 over 0, or if you have 0 in the denominator. A 0 in the top, we could have just plugged it in and got 0 over 1 and said the answer was 0. Yeah. You could do the algebra if only the denominator is 0. Or only the numerator is 0. But if the denominator is 0 and you get 0 over 0, people will tell me that's 0 as well, and it's not. So, if only your numerator is 0 and your bottom is a number, we could have plugged it in right off the hop and said it was 0.
You could have.
Right away. Yeah. I just wanted to show the tables because people completely forget about the tables. So if I give you something that's not 0, say I give you something that the denominator is still a 0, the top is something else, right? You can't get them to cancel off. You have to go to tables. That's the only way you can do it. You can't do it elsewhere. Right? So had it be swapped, like this, had I had x to the 4 minus 1 on the bottom, and x cubed plus 5x squared plus 6x on the top, you have to do tables. Because your denominator would be 0, and you can't get anything to cancel off. Does that make sense? So this way, with your numerator being 0 and your denominator not, you could have just plugged in. But if I had flipped my numerator and denominator, you have to do tables. Does that make sense? I wanted to prove the table part because people forget about that. And I can give you, AP usually gives 1, can't do algebra. They're testing the table. They're testing, can you do tables, which is a curriculum outcome. Okay? But you might have to calculate. There's portions that they test in calculators. So they're kind of forcing you to do it. Okay, this one, if I plug a 3 in, on the bottom I get 27 minus 27, which is 0. So I know I have to do some math. Right? Now, you can, different color. So you can go equals, the limit as x approaches 3. And you can factor the bottom by taking out an x squared. And you're left with x minus 3. And that's fine. But what did I tell you you have to do every time you have a radical? You have to rationalize it, right? Which means you have to multiply by the conjugate. And the problem is this. So if I multiply by it, it's conjugate. I get square root x plus 6 plus x. Now, distinctly with radicals, what was the step I told you had to do next, or it's going to be huge problems? Right. Distribute the radicals, but don't distribute the ones that aren't radicals, because you're going to embed the radical in. And my issue here is x minus 3. If you didn't notice, this is my problem. Because if I plug a 3 into the x minus 3, I'm going to get a 0, and anything times 0 is the issue, right? So I'm ultimately trying to get this top somehow to have an x minus 3, so this bottom x minus 3 goes away, and my problem is gone. All right? If I embed the radical in here, this x minus 3 is all embedded in there, and then what? Nothing. You're stuck. Right? So ultimately, this is what I'm trying to get to go away. So I don't want to put it together. But I do distribute at the top. So I'm going to get the limit as x approaches 3. Square root x plus 6 times square root x plus 6 is x plus 6. Minus x square root x plus 6 plus x square root x plus 6. The middle terms cancel, and they should if you have a conjugate. And then minus x squared. Over x squared, x minus 3, some nasty bottom. So on the top I have negative x squared plus x plus 6. What multiplies to give me negative 6 and adds to give me x? X plus 3 and x minus 2, right? But we have to do, we can't go right to brackets, can we? Because if your leading coefficient is actually a negative, you have to do decomposition. So we're going to go negative x squared plus 3x minus 2x plus 6. Take out a negative x, x minus 3, take out a negative 2, x minus 3. So I get negative x minus 2 and x minus 3. And I should start seeing happiness in your eyes, because you should see that the problem is going to cancel off, right? And so I'm left with the limit. I can plug in now. What am I doing? So the limit drops off and I can plug in. So I get negative 3 minus 2 over 3 squared times the square root of 3 plus 6 plus 3. So I'm going to get negative 5 over, I need to reset this board, it's off, 9 times 6. Square root of 9 plus 3. So negative 5 over 54. Did you get that? Yeah, no, maybe so. Okay. Now this one. We have to factor the right-hand side. If I plug a 1 in, I immediately get a 0 on that denominator, so I can't plug it in, right? I'm going to go back to grade 11 now, where I had to make common denominators. And so factors, I get x minus 1, x minus 2. So this one I'm going to multiply by x minus 2. I'm going to get the limit as x approaches 1 of x minus 2 plus 1 over x minus 1, x minus 2. And now I know this is my problem, right? So I'm hoping that cancels off, because that needs to go away or I can't plug in. When I plug my terms in the top, I get x minus 1 over x minus 1, x plus 2. Now remember, when these cancel off, what's left on the top? 1, which will drop off. So you get 1 over 1 plus 2, which is a third. For that one. Come on. All right. Then we have to do Newton's first principles for this one. So, f of x would technically be square root x minus 3. F of x plus h would equal square root x plus h minus 3. So, we would get y prime equals the limit as h goes to 0 of square root x plus h, f of x plus h, minus f of x all over h. Then it's very similar to that other one, right? You multiply by the
Sorry, but why did the
x minus 2 become x? Oh, sadness. It shouldn't have. I don't see any negatives here, but I should, because it should be an x minus 2. It's because I don't want to see negatives, remember? This doesn't work now. So we get 1 minus 2, which is negative 1. Oh my gosh. Equals negative 1. There. Fixed it. Solid. All right. So this one we need to multiply by the conjugate. Square root x plus h minus 3 plus square root x minus 3. And we don't multiply the ones that aren't conjugates, right? Because my problem is the h on the denominator. This here's my issue. It needs to go away. So I don't want to embed crap with it, or it won't go away. So I'm going to get the limit as h goes to 0 of x plus h minus 3. The middle terms cancel. And then minus, and then this is where the error happens. We're minusing x minus 3 all over h times that. So we can't forget to distribute that minus sign through, right? And you'll know you made a mistake, because remember I told you everything needs to cancel off that doesn't have an h in it? So the h's can, you take GCF out and cancel the h's off. So if everything that doesn't have an h doesn't cancel, you made an oopsie. So if I distribute that negative through, this becomes a negative, this becomes a positive, and that would become a positive technically. So the x's would cancel, the 3's would cancel. See, they wouldn't have canceled if I didn't remember that step. Now I have just an h on the top and an h on the bottom, so those will cancel. And then I'm still left with a 1 on the top. And then I can fill 0 in. So I get square root of x plus 0 minus 3 plus square root of x minus 3, which equals 1 over, what's x minus 3 plus x minus 3? What's x plus, yeah, 2x minus 3, because it'd be like x plus x, 2x. So that's using Newton's first principle. Now I told you, we also want to go through and be able to do chain rule. Why would I say chain rule? Because the whole thing is square rooted, which means the whole thing is to the half. Remember, in order to do a derivative, you can't have a root. You actually have to change it to a half every single time. Or its counterpart, like if it was the cube root of something, it'd be to a third. So say we use y equals square root x minus 3, which equals x minus 3 to the half. And it's a chain rule because I have something outside and something inside. And I can't do the derivative inside until I do the outside, right? Outside to inside, we always do. So y prime would equal, the half drops in front, rewrite the inside, and then what's a half minus 1? Negative 1/2, right? Because you subtract 1 from your exponent each time. And then I chain behind it the derivative of the inside. The derivative of x minus 3 is just 1, so it didn't really do much, right? Now, what can I do with this? I could rewrite it like this. This might make more sense for you if I do it this way. This is over 1, this is over 1. So this whole thing would be over 2, technically, right? And then I can take this and I can bring it to the bottom to make it positive. It's to the positive half, which I can rewrite as which is the exact same answer. So the good thing with Newton's first principles now is you guys can actually check them. So you still can be asked to do them, but you can check them with actual math and see if you got them right. Okay? All right, we're going to finish up doing some outer limits and derivatives tomorrow. We're going to turn to implicit differentiation. What the heck is implicit differentiation? Well, for now, we've always had y equals x's, or y equals u's, or y equals, and so it's been one variable on the right-hand side of your equation, correct? And we've always been able to change it to that. But now we're going to have more than one y embedded. And how do we deal with that? So we're going to do if I say determine dy over dx, that's me asking you for the derivative of y with respect to x. So y is on the one side, x's are the other variable, right? How many y's are in this equation? 1. When there's one y, you don't actually do it by implicit. You can rearrange your equation to get it into y equals, right? So we're going to do it in y equals, and we're going to do it in implicit. I'll show you the two. But when you have one single y, you do not have to do implicit. It's when you have more than one y that forces you to. Okay? So how could I get y by itself? Well, I have a division of y. So I can multiply by y. And so I get x equals y, or in this case, y equals x. And then I could go just right to my derivative, right? I just need to rearrange it first. This is the most simple I could give you. So dy over dx would be what? The derivative of y. Instead of writing y prime, I can write dy over dx, right? If this variable had been a u instead of an x, it would be dy over du. If this variable was a t, it'd be dy over dt. So it's just whatever the heck the variables are, right? I have to keep them x's because I asked you as the heading of this dy over dx, so they have to stay y's. So what's the derivative of x? 1. Okay, so that means the tangent slope at x for everything is 1. Y equals x is what line? Yeah, it's that identity line. It's the 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1, negative 2, negative 2, right? And a slope of 1 does what? Up 1 over 1, doesn't it? So tangent slope of a slanted line is itself, right? It's the only way you can get that 1. That's why it has to be the 1.
For any line that's not like round over everything that doesn't have like multiple slopes, it's always just going to be one number as the slope.
Yep. And it will be whatever its slope was. Yeah, exactly. Now say we want to do this implicitly. You're like, I don't know how to do that. That's okay. I'll go over it. Okay. You don't know this, but every single time we've taken a derivative of an x, we've actually dx behind it. We just didn't write it because dx divided by dx is 1, right? So had I done this, y equals x, you're technically doing this. You're going dy over dx. You're going to show all the steps. The derivative of y is just 1, right? And then you're putting, oh, it's dy with respect to x. And then this one, you're going, oh, it's 1. Okay, it's dx with respect to x. That's what you're doing every single time. Dx divided by dx just cancels off, right? And you don't have to write the 1 in front. So that's how we're getting dy over dx equals 1. So every single time you're doing an actual derivative of anything, you're following behind with that variable over itself. With the derivative of it, you just don't show it because it would equal 1 every single time. So the only time we're going to show it is actually in implicit, because we're going to have mixtures. We're going to have y's and x's. Okay. So on the left side, we have two things divided. So what do we have to do when we have two things divided? And we want to find the derivative of them. What rule? Quotient rule. So we have to go f prime times g minus g prime times f over g squared. Correct? When it's a monomial on the bottom, instead of doing quotient rule, what could we do? Bring it up and make it a -1 and do power rule, or product rule, which is what I'm going to do. So I'm going to go x y to the -1 equals 1. And then I blatantly do this to remind myself that two things are being multiplied. You could do either. Product or quotient, it doesn't matter. You just do quotient right off the top or product by moving it. But you can only do it when you have a monomial in the denominator. Can you choose to do it as product? So, this would be f, this would be g. F equals f. F prime equals, technically, 1 dx over dx, which cancels to get a 1. And then g equals y to the -1. G prime equals -1 y to the -2 dy over dx. And that has to stay because it doesn't cancel off. So technically, you're going to be left with dy over dx when you take the derivative of y's and nothing when you take a derivative of x. Does that make sense? So product rule is f prime, which is 1, and g, which is y to the -1, plus g prime, which is negative y to the negative 2 dy dx, equals, and this is where people error, and I don't know if it's you, but this is where I error every single time. I write 1. We take the derivative of everything, right? What's the derivative of 1? I forgot to do the s. Just an x here. How do we do the derivative of that? What's the derivative of 1? What's the derivative of any constant? 0. So everyone will do the convoluted, ugly derivative on the one side, and then they'll write 1. But remember, you have to do the derivative of both sides. The derivative of 1 is 0. Now I'm going to write so it doesn't look nearly as up. So I'm going to have y negative 1 plus minus x y to the negative 2 y over dx equals 0. I'm just rearranging it for my own brain. Now our full goal here is to actually get dy over dx by itself. So, what do we have to do? We will have to subtract the y minus 1 over, because these are being multiplied by the dy dx. So we subtract y minus 1 over. We get negative xy squared dy over dx equals negative y minus 1. What? This here? Yeah. Then what are we going to do? I hate smart boards. I lose things on them. They're so large. If you write tests on smart boards, people would be in trouble. We drop things off. What do we do next? We want to get dy dx by itself. Yeah. Mm. Let's see why this method sucks if you have it in the other one. So if we want to, we can actually swap those y's, right? We can bring the y to the negative 2 up, make it positive, y to the negative 1 down, make it positive. But this negative 1 in front doesn't move, right? That's a negative 1. It's just the y that's to the negative 1, not the negative 1 in front. So the negative 1 stays. Y to the 2 up here, negative x, y to the 1. The negatives can actually cancel, right? This y can cancel off one of these. So you get y over x. And then people say to me, well, that's not 1. Your last step in implicit is to plug in what y is, or what y was. So we go back way up to the top, and we'd have to actually isolate y by itself anyways. And we find that y equals x, correct? So if y equals x, I can plug an x in there. So I get x over x, which is 1. Sometimes they plug in for the y, and sometimes they don't. That's a heck of a lot more work, right? Why do I show this example first? Because if there is a single y, please just isolate for it first to find the derivative of it. Do not do implicit. It is awful. Like, that's a lot more work, right? Still got the same answer stuff. Okay, let's do one that's not set. Actually, I'm going to give you one that is set. Number 2. You're going to find dy dx of xy minus 4 equals 0. So you're going to try this one out. How many y's does it have? 1. So what are we going to make sure we do? Get the y by itself, and then do the derivative of it. Don't pick implicit unless I force you on these ones. That's really, really not fun. So isolate your y. So I'm going to add 4 over. And I'm going to get xy equals 4. Then I'm going to divide by x. And I get y equals 4 over x. And then some people do quotient rule. But I know that whenever I have a monomial in my denominator, I can bring it up to a negative exponent. I do power rule in this case, because the top is just a number. So I'm going to go y equals 4, x to the negative 1, and then do power rule. I don't even have to do product because this doesn't have a variable. So y prime equals negative 4, x to the negative 2, and then drop that down. Okay? Okay, number 3. One that you can't do this with. Or, well, you won't want to. 3x squared plus 4y squared equals 2x. Do I have a single y? Technically, people could fight me and say yes, but it's a y squared, right? So I would have to subtract the 3x squared over, divide by 4, then take the square root. So I would have a chain rule with a quotient rule embedded in it, right? So in this case, when it's not just a single y, we just do implicit, because it actually is faster. When it's a single y by itself, that is faster to get it by itself, but this isn't going to be. I'm going to have 2x minus 3x squared divided by 4, all square rooted, so all to the half. I'm going to have to do chain rule, quotient rule. Ugh, not fun. So these ones I'm going to actually do implicit. So all I do is I just do the derivative of each of them separately and move along. Okay? So the derivative of 3x squared is 6x, technically, times dx over dx. But what happens to that dx over dx? It becomes a 1, right? So do I have to write it? No, but you can. Then I'm going to do the y. 2 drops in front. 4 times 2 is 8. Y to the 1. Do I have to write the 1? No. But this is where people error. They forget to do this. Then I multiply it by dy over dx. Does that one cancel off? No. Then equals. Derivative of 2x is 2 times technically dx over dx, but it cancels. So the first step in implicit is just do the derivative of everything. Treat each term separately, do the derivative of them. Then your last step to get it is to get dy over x by itself. So I technically have 6x plus 8y times dy over dx equals 2. So the first thing I'm going to do is I'm going to subtract the 6x. So I get 8y dy over dx equals 2 minus 6x, and then I divide by 8y. Dy over dx equals this. And that will be the answer in the book. They're not going to make you insert the y back in. All right. We could take a 2 out of all of them. Okay? They're actually probably not going to give that. They're probably going to give the answer to this. 1 minus 3x over 4y. The number has to come out of all of them or not at all, right? All right. Now, what if I take that exact same one and I ask for the tangent slope? Exact same question. So this, we'll label this A. Now B, I want the tangent slope, or I could say instantaneous velocity, right? Same thing. Or I could say rate of change. Tangent slopes at 1/2 and -4. Or -1/4, sorry. -1/2. 1/2 and -1/4. Now, tangent slope in the past, once I got my y prime, I just plugged the x in and got my slope, correct? This one just happens to have x's and y's. So you just need to plug in both for the right variables. That's all. And if I don't give you y, how do you get y? Do you remember? If I gave you just x, plug x back into the original and you can get the y, right? That just makes the question a bit harder if I don't give you directly the whole point. All right, so we're going to go dy over dx equals 1 minus 3 times 1/2. Now please try and do this without your calculator, because half of your test does not have a calculator, right? So you have to be able to do fractions without them. So practice without it at first. So we're going to get 1 minus 3 over 2. And then 4 times -1 is -4 over 4, which is -1. One is the same as writing 2 over 2 minus 3 over 2 divided by -1, which is -1/2 divided by -1, which is 1/2. Everyone get that? Yes? What's the last thing I could ask you for? Yep. The tangent equation. At 1/2 and -1/4. So then we just do our y equals mx plus b, right? Nothing has changed. Nothing is different. Y is -1/4. M is 1/2. X is actually 1/2 plus b. -1/4 equals 1/4 plus b. Minus 1/4 over. B equals -2 over 4, which is -1/2. Because when you subtract or add fractions, you keep the denominators and do the math to the numerators, right? So we're going to get y equals 1/2 x minus 1/2. The harder part is checking these ones because the original is not in y equals, right? So you'd have to actually get the original into y equals, to type it into your calculator, to type this into your calculator to see if they actually are tangent at the point 1/2, if they meet there. So these are a little bit more work that you can't check them as quickly with your calculator because you actually have to get the originals into y equals. Okay? Okay, what if I give you one like this? It's our last one for today. And then we're going to do tomorrow, first part of it, we're going to do what if I ask you for the second derivative instead of the first, and have to do implicit. Okay? So, determine, I don't know, we're on 4. Determine y prime of e to the y cos x equals x plus 1. So once again, our y isn't just y equals, right? Every single time we've had this before, it's been e to the x, correct? Not e to the y. So when your y can't be just by itself on the left side of the equation equals everything else, you have to do implicit. There's no other options. So we're going to go e to the y cos x, I'm just rewriting it, equals x plus 1. e to the y cos x, what am I going to have to do? Yeah, product rule. Two things multiplied, right? When I do product rule, I go off to the side and do my f and my g first. So f equals e to the y, which is the same as e to the x, technically, right? And derivative of e to the x is e to the x. Yes? So the derivative of e to the y is e to the y, but what do we have to watch out? When we take the derivative of a y, what happens? What do we get behind it? dy over dx. That's the common error, forgetting to write that dy over dx. Because ultimately that's what we're going to try and get by itself at the end, right? And then g is cos x. What's the derivative of cos x? Negative sine x. And technically I could go behind it dx over dx, but what happens with that? It just becomes a 1. So it's just negative sine x, right? So it's only the y's that I have to follow behind with dy over dx, and only when I take the derivative of them. So what people will do is they'll stick a dy over dx in front of this f1. But f is just f. I didn't take the derivative of it, right? So I only have to put the dy dx if I took the derivative. So I'm going to go f prime, which is e to the y dy over dx, f prime, times g, which is cos x, plus g prime, which is negative sine x, times f, which is e to the y, equals the derivative of x is 1, technically dx over dx. It just happens to cancel off. And then what's the derivative of a plus 1? That's the derivative of any constant. 0, right? So we don't have anything behind that. Now, what did I tell you our goal is after this? After we've taken the derivative of each thing separately, our goal is to get dy over dx by itself, right? If you forget to write a dy over dx, you're going to sit here staring at it and go, oh crap, I don't know. Like, you'll actually call me over and you'll be like, how do I get y equals when they're in the very, then you're logging them. It's just a whole debacle. So, if you remember the dy over dx, this question's easy to do. If you forget the dy over dx, you kind of get stumped and you want to get the y's by themselves or something like that. Okay? So, the first thing I'm going to do is add the sine x e to the y over. I like writing the dy over dx at the end. So I'm going to add this over. I get 1 plus sine x e to the y. And then all I have to do is divide this over. Do I know the biggest error? People thinking they can do way more reducing than they can. That's it. That's as pretty as it gets. But people will go cancel these EYs off. Can you? You can only take an EY off if it's e to the y off if it's in every single term, right? Just like when we took a 2 out, it was in every single term. Is there an e to the y in every term? Yeah, but then this is embedded with it. It's really weird. If you take an e to the y out, then your dy dx is embedded in this weird inside part, and we're trying to get the dy dx by itself, right? So then you're sitting there like, oh, what do I do next? Right? So it's just easier if you just, because then you'd have to divide the e to the y over, then you'd have to move this over, and then you have to get a common denominator negative, which is going to work. So we get dy over dx. And the only way you can go further is if I give you like a coordinate and ask for tangent slope or something, right? Then you can go further. And often, I'm going to tell you this, if it's in the non-calculator section, they're going to give you x's and y's. In this case, they're going to give you y's for sure as 0. Because e to the 0 is 1. You don't need a calculator for that. So if I was the person making this AP question without a calculator, I would make the y for sure be a 0 if I was asking for tangent slope, because it would be e to the 0, e to the 0, which is 1. E to the anything else is decimals, right? So you'd have to be able to leave them as e's. And I'd make this one be like 1s or 0s as well, because cos of 0 and sine of 0, or sine of 1 and cos of 1 is quick. So I would make this be like 1, 0, or 0, 0, or something like that, if it was in the non-calculator section. If it was like y was 3, then they would allow you to leave this as e to the 3 and e to the 3 and not mark it down as a decimal, because you couldn't. You're in a non-calculator section. Okay, so your homework. It's page 237. I'm just going to do the actual problems first. So numbers 15, 17, and 53. And then page AP, numbers 1, 3, 5, 8, and 10. Now guys, I'm leaving this up to you. I'm not giving you an immense amount of work. That's not a lot, right? They're just single questions. But if you're like, okay, you did 15, 17, and 53, and you're like, I still don't know exactly what I'm doing, or I need more practice, do more in that section. Always just do the odds, though, right? Because the odds actually have an answer for them. But like if I went and did 15 and 17 and I was struggling, I would be like, or I'd be like, hey, those don't have trig in them. I want to practice the trig one. Then I would go down and do a couple trig ones or E ones. That's up to you. Because that's what university is going to be like for you guys. They're not even going to give you an assignment questions usually out of your textbook. They just let you do whatever and they give you an assignment to do once a week or something like that. Okay? So I don't want to give you 700 questions. I want you to practice. These are the minimal you have to do. Minimal. These are obviously minimal. I gave you 3. But I would, if you have time, practice more. Okay? Pause it. I have an assignment posted in Google Classroom to hand it into. Yeah. And it had the answers, right? So I just expect that if someone doesn't know what they're doing, they're going to ask questions. Chain rule is one of those that needs lots of practice. Implicit, if you can wrap your head around the steps, and you can see the product rules and quotient rules you have to do, implicit's not a bad one. Because they don't give you really ugly product and quotient rule questions to do. They're like nice ones, but you just have to spot them. So your derivatives of inverse trig, derivatives of logs, left, and I usually do related rates in here too. So we have 3 lessons left. Your test will be next week because I'm going to keep practicing with you and move on to the next unit because the next unit uses all the derivatives from this unit. Remember I told you that you have to do that anyway? So it won't harm us to move on. it's still going.